Okay, so the next part of our chapter, which is on sequences and series, is section 4, arithmetic series. Now, when you add up the terms of an arithmetic sequence, you get an arithmetic series. So if you just want to write that down first for your notes. So when you add up terms of an arithmetic sequence, you get an arithmetic series. Okay, and there's two formulas that are going to be really key to this one, this part of the chapter, and that's going to be how you find the sum of an arithmetic series. So to find the sum, S of n, you would always do n divided by 2 multiplied by 2a plus n minus 1 d. Now you should hopefully remember that a is the first term, d is the common difference, and n is the number of terms that you have. This formula is in the formula book that you get given when you do your exam, so you don't need to learn it off by heart, but you do need to know how to use it. There is another version though that we can also use, which starts with n over 2, and this one you do a plus l, l being the last term of your series. Okay, so these two here, you can write that they're in your formula book, so it's always good to make sure you know where they are, but they will be given to you. Okay, so let's use these and see how to put them into practice. So my first example says, find the sum of the first 30 terms of an arithmetic progression with first term 8 and common difference 0.5. So if I have first term 8 and common difference 0.5, what we're trying to find is the sum of the first 30 terms. So because I've got a, d and n, you can just use the top formula and figure that out. So sum of the 30 terms would be 30 divided by 2 times 2 times 8 plus, it would be n take away 1, remember, so it would be 29 times d. And you can just put that straight into your calculator to get the answer. Okay, so that's 457.5. Okay, and then the next one of this example, so this is part B, says the first term of an arithmetic sequence is 12, so A is 12, and the 50th term is 525. So U of 50 equals 525, because remember, term we use U, that's what we learnt previously. Find the sum of all 50 terms. Okay, so with this one, I've got the first term, and because I want the sum of the 50 terms, I've also got the last term as well. So we can straight away do sum of 50 using the second formula up here is 50 over 2 times 12 plus 525. Which is 13,425. Okay, so another one. This time we've got a sequence that has first term 5, common difference 10, and we know that the sum of the first n terms is 720, and we want to find n. So for this one, we are looking for the n's. We use the first formula because we've got a and d, we don't know l, and we're actually trying to find the n because we know what the sum is. They've given it to us as 720. So I can put that 720 equals n over 2 times 2 times 5 plus n minus 1 times d, which is 10. So you end up with this expression. So we have to do some rearranging to figure out what n is. So I'm going to first times up this 2 here. So I get 1440 equals n. And then I'm going to tidy up this bracket. So I've actually got 10 plus, remember this is 10 times the n and the take away 1, so 10n take away 10. Well, 10 take away 10 is going to be 0, so they're actually going to go. So I end up with just 1440 equals 10n squared. So divide by 10 gives me n squared, and that would mean n is the square root, and it will only be the positive square root of 144 because we're not going to have a negative number of terms. Okay, so we always start with n is 1, then 2, then 3, etc. So it will be 12. Okay, then my final example, number 3. For this one it says find the sum, I'm going to write this one out, of all the multiples of 3 between 100 and 1000. Now what we need to first of all think about is what this sequence would look like. So the first multiple of 3 after 100, well I know that 99 would go into 3, so the first one after 100 would be 102. And if I do s of n here, then it would be 105. It would just be going up in 3s, and then eventually we would get to the last term before 1000 that would divide by 3, which would be 999. So I now know that there's a lot of numbers in between here, and rather than trying to count and write them all out, what I can do now is I can figure out what number term this is. So using this formula which we used last time, if you remember, this tells us how to get an individual term in a sequence. So if I want to know what term number 999 is, I can put 999 here. I know A is 102, and then I know the common difference is 3. So we can do 999 take away 102 is 897. And that would equal 3n minus 3 if I expand that bracket. So adding on 3 gives me 900. Dividing by 3 gives me 300. So 999 is the 300th term in the sequence. Therefore, to find the sum of all these terms, so the sum of the 300 terms, I can use either of the formula now from the beginning, but since we actually have the last term and the first term, I'm going to use the second one. So I'm going to do 300 divided by 2 times, and it's A plus L. So that would give us 165,150, so quite a lot. Okay, so you should now be able to try exercise 4D. Now for the drill questions, I'm just going to give you the solutions, like the answers, but then what I've done is for the green and the blue questions, from listening to a bit of feedback, I've actually done those as worked solutions, so you can see straight away how I've gone about learning those. And then I was asked to do the red ones as video solutions, so I'm going to do the red questions now in video form so that you can see my thought processes of them, and all of this will be in Microsoft Teams. Okay, but you can still email me if you get stuck. Okay.